everyone, welcome to the Mjic 2026 Virtual Innovation Pitch. Our project is titled Enhance Anode Performance via Porous Activated Carbon Derived from Biomass Waste for Lithium-ion Batteries. We are from University Science Islam Malaysia. Today, we are bringing something simple, sustainable and honestly quite cool. We are turning coffee grounds, bamboo, coconut shell and tea leaf into activated carbon for lithium-ion batteries. Why? Because green energy starts from green materials. Let's begin. Now, you might ask, why bother with biomass waste at all? Here's the real problem. Graphite anodes are good but not perfect. They are costly, not super sustainable and production isn't exactly eco-friendly. Meanwhile, Malaysia produces tons of biomass waste every single day. So, why throw it away when we can turn it into something powerful? Now that we know the problem, it's time to show our campaign. Our objective is to convert biomass waste into activated carbon using HTTE and evaluate its structure and conductivity to identify the most promising anode material.
Now, we arrive at the methodology of our innovation. Our process starts by preparing the biomass, sieving, drying and storing it properly. And then, we mix the material with potassium hydroxide as the activating reagent in controlled mass ratios, which is the main variable of our study. The next stage of our methodology is the hot tube thermal evaporation process. The mixture is heated in a tube furnace under argon environment, ramped to 700 degrees Celsius, held for 2 hours and left to cool naturally. The product is then washed with dilute hydrochloric acid and raised to neutral pH. Lastly, the samples are dried in oven overnight to obtain porous activated carbon. Finally, we verify its structure and performance using a few analysis instruments for a comprehensive behavioral study of the sample. Here's what makes our project stand out. We compare 4 different biomass wastes, which are coffee grounds, bamboo, coconut shell, and tea leaves using the same HTTE process. This side-by-side comparison for lithium-ion battery anodes is rarely done in previous studies, giving a clear benchmark for a sustainable, high-performance carbon materials. We also have copyrighted our method in producing the activated carbon since April 2025 after a preliminary and optimization study has been carried out.
So, did all 4 of our biomass waste successfully turn into porous activated carbon? Of course. But did our experiments actually work? Let's check the results. We first tested all of the activated carbon derived from the 4 biomass waste using field emission scattering electron microscopy analysis. From the photos shown, we can clearly see the pores formed on all of the samples. But how do we confirm that our samples consist of high carbon content? We can confirm this by energy distributive X-ray analysis, which reveals that all our samples contain high carbon beads. We also conducted a Fourier transform infrared spectroscopy test to verify that all carbon bonds are present in the samples. Meanwhile, the X-ray diffraction test confirms the amorphous structure of the activated carbon that has been cleaned and neutralized thoroughly. After converting all activated carbons into anodes and testing them using electrochemical impedance spectroscopy, we found out that the activated carbon from coffee grounds has the lowest value of resistance and the highest value of ionic conductivity, making it the most promising material for anode for lithium-ion batteries among all 4 biomass wastes.
So, why is this project exciting and useful? First, it is low cost. We are turning everyday waste into valuable material. Second, it is eco-friendly, reducing biomass going to landfills and also lowering the environmental impact. Third, it is scalable. The industries can adopt this process with large amount of waste. And finally, it contributes to global goals SDG 7, 12 and 13, which is clean energy, responsible consumption, and also climate action. In short, ordinary waste can have extraordinary value and can powering both batteries and also sustainability. Coffee shops, coconut industries, bamboo and tea farms all produce waste daily. This project allows turning that waste into battery-grade material. It opens up new green tech market opportunities and supports the growing demand for sustainable energy solutions.
Our project has already gained recognition in internal university competitions and science fair. We are also preparing to share our findings in journals and conferences so others can benefit from sustainable and high-performance battery materials. This shows that innovations and sustainability can go hand in hand with real-world impact. So our project turns everyday biomass waste such as coffee grounds, tea leaves, bamboo, coconut shells into high-performance, sustainable battery materials. Remember, innovation doesn't always start with high-technology labs or big budgets. It can start with simple ideas, curiosities, and determination to make a difference. Thank you, Mjic 2026.